Here's a problem going over a ramp. First step, free body diagram. I know I have the force of gravity. Straight down, I have the normal force, which is perpendicular to the surface. Right, again, here's my surface. There's the normal force, that's perpendicular. I have tension. Right. And then we said we have to do our doggy axis. So remember, it's like you're taking your head and you're tilting the problem. Right? So I have to then break up my force of gravity into components. So this is my force of gravity in the y, and this is my force of gravity in the x. Okay? So there's my free body diagram. Now solving this, okay, it says what is the value for tension? Well, tension, that is from my F net statement. That's my next step. So I would do F net in the x equals MAX. So what force is going down the ramp? Well, that right here, that's gravity is going down the ramp. Right? So I'd say force of gravity in the x minus tension equals MAX. Now the object is held at rest, so this is 0. So then I could add tension to both sides, and I'm left with force of gravity in the x equals tension. Force of gravity in the x, okay? Well, we told you FG is the same thing as mg. So my hypotenuse here is mg. Here's my angle, that's 30 degrees. And FGX is the opposite side of my triangle. So this is the hypotenuse, which is mg times the sine of theta equals tension. Once you do the math to that, you're going to get 100. So tension equals 100 newtons. Okay. All right, on the next one, what is the acceleration of the block if the rope was cut? Well, back to solving problems. I get it from my free body diagram. What's different in this problem? Well, in that one, right, if I had to get rid of some of these things, what's left over? Well, gravity's still there. Normal force is still there. And then I have to break down my components. That's normal force. And then I have gravity in the y and gravity in the x. Again, we're solving for problem C here. So I do my F net. The only force I have there is FGX equals MAX. We said FGX is mg sine theta equals MAX. Here's an interesting thing. If I divide both sides by m, mass cancels out. So I'm left with g sine theta equals acceleration in the x. So mass doesn't even matter. Okay? Test yourself and do the math. Okay, but I know this one is going to be 5 meters per second squared. Okay. Going down to the very last problem. How long will it take the block to slide down the ramp? Well, this is going to be kinematics. I know the initial velocity is 0. I know the acceleration is 5 meters per second squared. And I know the length of the ramp is 5 meters. So my kinematic equation I would use is change in x equals v initial t plus 1/2 at squared. V initial is 0, so 5 equals half of 5. times t squared. Right? Showing my algebra, this is going to be times 2 times 2, divide by 5, divide by 5. So t equals the square root of 2 seconds. Good luck working on your other problems.